So today we'll be seeing some important points regarding your M.Tech course registrations, dates for M.Tech applications. We can see especially for metallurgy, IIT Bombay offers very good M.Tech courses, which pays more than with an average package of 15 to 20 lakhs. Okay. And recently it has added many more M.Tech programs to the Department of Metallurgical Engineering and Material Sciences. So especially we are making a main video regarding this because this course also offers lot of scope for metallurgical engineers and material science engineers. And we'll see what are the details regarding those courses. So in this, first I want to tell uh, the site for your IIT Bombay registration. This is the Department of Metallurgical Engineering and Material Science. In academic blocks, if you'll be seeing UG registrations, and then you see M.Tech programs. There is also an option for direct PhD applications. If you have a very good CGPA, you can apply for it. That will be along with masters plus PhD. If you get a very good CGPA, you can apply for it. So let us see each of these courses today. What are the course details which are there? What courses will you be able to learn in them? What extra benefits you'll be be getting if you learn these courses? How will the career prospects of these M.Tech courses? Okay. So firstly, it is divided into previously, like 2 years ago, if you'll see, last year itself, if you see, you have only material science, steel technology, corrosion science, and there is one more branch which is called as process engineering. Now they have removed it. So material science, steel technology, and corrosion science are the oldest M.Tech programs only. Recently, they have added computational material engineering, semiconductor processing, steel technology is old only. Materials manufacturing and modeling. Previously, it used to be a part of mechanical engineering. Okay. So people who used to write GATE from mechanical backgrounds, they used to have this course for M.Tech program, which is called as Materials Manufacturing and Modeling. So what they have done is, depending on the requirement of the industries, like automobile, they generally started with an idea that they need industrial oriented courses, especially for materials manufacturing, which people belongs to mechanical background. Okay. Then see, this used to be actually materials modeling and mathematics previously. Then it came into modeling and manufacturing. Mathematical department went out of the M.Tech program. Now, previously, when it used to be there, you used to have all science courses, everything used to be included before the AML was known larger itself. Okay, at the starting itself, they have started it. So this is also a very good branch to be keep in note. Now, how the course design will be for each of these M.Tech courses, we'll see what are the credit requirements, what are the extra things you need to do in order to get minors also in this course, we'll see it. Okay, and keep in mind that if while you do an M.Tech from metallurgical and material engineering, you can also have a minor in mechanical engineering. So only for MEMS, the only branch where you can do your minor engineering is you from mechanical engineering only. So along with your M.Tech degree, you'll also be getting a minor degree from only mechanical engineering. No other departments you can apply for it. Okay. But the courses you can apply anywhere. Those are called as open electives. We'll see about them also. Okay. First, let us see about this one. Computer, just one idea. Let me First, let us start with the branches which are already there in your this one. Okay, let us see. So material is the best. Next is corrosion and steel technology. These are the brands which are there from the past itself. So let us see about them first. Then we'll do the newer courses also. Okay. First, so in Department of Material Science, you need to do at least core courses in semester 1 and in semester 2 12 credits. So totally first semester only core courses. These are compulsory courses which you need to do, especially which is related to only material science. Okay. Next is elective. Elective is something which you can select anywhere, any other department also you can select other courses which are not from the core courses. Okay. Next is institute elective. Institute elective is something which you can select except your branch. Every other branch you can select one course. You can do it as an extra course. So you need to do compulsory one course which is not from your department. And electives can be your department elective. Means suppose if you are doing material science, you can do a course from corrosion, or you can do a course from semiconductor also. Like these kind of courses also you can do. Next is lab course. One semester, first semester you need to do one lab course. Second semester you need to do one lab course. You'll be having one seminar. You'll be having R&D project is not for us actually. It is for 3 years M.Tech course, which is called as research. So they will have, next is communication skills. So totally you need to do first semester 33 plus 6, second semester 37 credits. Third semester onwards, you will be having a project which is of 50 credits, and fourth semester again you'll be having a project. So you can complete your electives in your third and fourth semester also. Generally people try to complete everything in their first and second semesters so that they can have sufficient amount of time for their placements and preparations, because they'll be having only projects. So you need to do completely 166 plus 6 credits. So let us see what is this 166 credits. Thermodynamics of materials. So this thermodynamics material starts with basics of thermodynamics. Then they'll be going deeper into solution thermodynamics, just like how you have in engineering, but in deeper terms. Like you'll be having more rigorous application of Gibbs free energy, solution thermodynamics, regular parameters like interaction parameters, whatever you have. All these you'll be learning in a deeper version. Decomposition, spinozal decomposition, and other phase transformations also you'll be learning this phase diagrams, application of thermodynamic learning in this course. It's a very important course and it is a core course for you guys. Next is structure and defects. So you'll be learning all these. There used to be a course called Physics of Materials. So in this, you'll be learning all these and like the similar kind of course only you'll be having with structure and defects also. Next is electrical materials. So you have fundamental applications of these electrical materials. You have learned about electrical properties, magnetic properties, and so the uh, different kind of properties you might have learned. Optical properties also you might have learned for the materials, right? So you'll be learning an extra thing which is electrical materials fundamentals and its applications in materials especially. Next is the structural characterization of steels. So this is a half semester course in which you'll be having about XRD and SCM characterizations. You'll be having it mainly SCM and a small part of the TEM, and large implication of XRD you'll be having in structural characterization of materials. Next is mechanical characterization of materials. All the mechanical characterizations include these the tensile test or torsion test, different kinds of hardness test. Everything will be coming under this mechanical characterizations. Next is electrical characterization. All the electrical applications or electrical characterization of these materials, how to do it and what will you do it. These applications you'll be learning in this course. So it's a half semester course in second half. First half you'll be learning only structural characterization, because whatever project you do, you will be using SCM, XRD, everything to study your material. So it's a compulsory course for everyone. Out of these courses, mechanical characterization, electrical characterization, material characterization at high temperature. So at high temperature, how will you characterize? We used to have a equipment called SEM when I used to study in IIT Bombay, where at higher temperature, if you heat it, the material will start dissolving, it will start turning into liquid phase. So during this liquid phase, how the phase transformations happen, what kind of phase transformation happen, these characterizations you can study. So you also have characterization of materials for corrosion control. So out of these forces, any of the topic you can be selecting it. Next is one department open elective. You can select any department open elective, provided materials processing and characterization lab, which is called as thin film techniques. So you'll be learning about thin film formation or thin film techniques on the material, how a thin film can be coated on the material, vapor deposition techniques, different kinds of techniques will be there. These are the things which you'll be learning in this lab. Communication and presentation skills is compulsory for everyone, which you will be doing in first semester. Next, second semester. Second semester, you'll be having a topic called diffusion and kinetics. So this is more of mathematical application. So you'll be learning rigorous mathematical differential applications in diffusion and kinetics chapter. Okay. So this fixed law of diffusion, whatever you know, you'll be applying it a higher differential applications. And along with this, you'll be also doing some mini projects in this course where you'll be doing mainly using MATLAB. So MATLAB, there is a course related to MATLAB in first semester. You people can enroll for it. They'll be teaching you all the basics which is required for the MATLAB. And you can do a small project on this topic, taking a paper and using MATLAB, you can write all this mathematical modeling. Next topics in mechanical behavior of materials. So it is all of whatever mechanical behavior, these things are there of the materials, you'll be learning in it. You can select a department open elective 2 and 3. So overall, you can select extra 3 courses in the department itself, 1 in first semester, 2 in second semester. Then you have one more institute elective. Generally, people prefer to take machine learning or probability and stats applications in these institute electives for learning in second semester, so that they can be ready for their placements also. But you can use this in your project also. Okay, as a part of project also you can use it. Next is material processing and characterization lab 2. These are bulk techniques. You'll be learning all these characterization techniques for the materials, especially in the lab scale. So bulk techniques you'll be using it. Okay. So you have different kinds of bulk techniques. We can this is not a session where we can have more deeper things. So this is seminar. So seminar is about you'll be taking a topic. First main thing is you will be learning about literature review, how to read a paper, how to write a paper. All these things you'll be learning here. You'll give a presentation related to a topic. You'll be explaining it. Next, again, department open elective 4. You can complete this in your first 2 semesters only. Next thing will be project. Project need not be only related to material science. You can take any kind of project which professor agrees actually. So if you take a project which is related to corrosion, if the professor agrees for you to do a project on corrosion, you can directly do it. It is not related to your M.Tech course directly. Generally, people prefer to do material science projects only because they have done a lot of specialization in those. They have become mastered by doing some courses, right? So selecting is not a bad idea also. If you want more interest towards or keen interest towards other topics, you can select this also. Next is corrosion. See, corrosion also has a lot of importance. Many people, many industries also require corrosion specialists. So what are the courses offered here also we'll be seeing it. So if you see, core courses are 18. So including summer, this is not required. So 6 will be there. Electives 12 and 12. In third semester, you can do one elective extra. So 24 credits in first and second semester. Core courses, you need to do 24 credits. So mostly what is this 24 credits is each course will be 3-point course, 3 credit course, or a 6 credit course, or a 4 credit course you will be having. 4 credit course are generally labs and seminars. 6 credit course are generally core courses, very important courses. You should not lose much marks in this. This will affect your CGPA. And you have half semester courses which are of 3 credits. This is a full semester course which is of 6 credits. So you need to do at least 24 means you need to do at least 4 core courses. Electives 30% means you need to do at least 5 credit courses. So institute elective, you can do one. Lab course, you'll be having one. Seminar one. Like this, you'll be having. Total, you need to do 158 plus 6 credits. So what is this? So you'll be learning all the things which is required mainly for corrosion application only. First is aqueous corrosion. It is also a very good specialization. So mainly you'll be learning about aqueous corrosion and its control. So especially in the liquid medium or aqueous mediums, presence of humidity, these all things you'll be learning in corrosion and its control. High temperature corrosions. So high temperature oxidations, high temperature corrosions, you'll be learning this. Then there is structural characterization, which I already told you, XRD and XRD, SCM, you'll be learning more. And there are very small techniques, WDS techniques. EDS and EBSD is only covered to smaller extent. Next, this is a core course for your corrosion engines, because characterization of material for corrosion control. Material science and other groups have an opportunity to select other courses, but they have only corrosion control. Next is corrosion laboratory. Next is restricted elective, department open elective. Next, in second semester, you'll be having protective coatings. This is the major scale where HPCL, BPCL, IOCL are working on projects of corrosion protective coatings. So inside to protect their pipelines, there are many projects in IIT Bombay where this BPCL and IOCL has connections. So they were working on how to protect the inside lining of the pipelines. So there is an project which is going on protective coating. There are many projects which run long term. Okay. So seminar, communication and presentation skill is common. Next is project and credits. That's all. So restricted electives. You have an extra part. I told you electives is like something which you can select from three different. One is department elective, one is restricted elective, one is these open elective. Open elective is institute elective. Wherever you want, you can select it as special as apart from your department. Inside department elective, you can select only department courses which are being offered. Now, restricted elective is something which you need to take only from the list which is provided. So restricted elective, you can take electrochemical material science, advance in design and corrosion control for industries, thermodynamics of materials. I told you in material science first course itself. Diffusion and kinetics, materials, fundamentals and applications, mechanical behaviors, you can learn XRD. Now, X-ray diffraction and electron microscopy. First, suppose the people who have learned a course in this, which is structural characterization of materials, you will be having an idea of how to the basics of XRD and basics of SEM. Now, this is most advanced course. Suppose if you want to be, or if you want to learn XRD, like the professor there teaches in such a way, the course itself is defined in such a way that you are doing the real applications. So many examples will be taken. Many the projects which were done, actually those were taken as live examples, and mostly the recent applications only will be taken out. And XRD you'll be learning in such a way that the real implications, how the machine is working, how you are calculating everything will be learned in a detailed version. And electron microscopy also, you'll have a very good expertise in it. Okay. So if someone has much interest in moving towards electron or XRD specializations, please select a course from this, because you need a PhD. You need if you want to go to any PhD or any higher studies, this course will definitely help you. Next is structure and defects, which is common. Department of open electives. So from the department open electives, you can select welding science and technology. This is also a very good course. You'll be learning about welding in a very deeper versions. You'll be learning about all ternary phase diagrams and all these things you'll be learning again in a very deeper versions. Engineering polymers and composites, colloidal sciences, modeling and analysis is something which is related to your software kind of things. Numerical methods is also one good course where you'll be doing all application oriented material processings. Okay. Next is plasma processing. This is a very easy topics. You can learn a little implication of how to how to process a material along with plasma. You'll be calling it as plasma processing of materials. Next, you have a course which is department. So in steel technology, again, core courses are 39 credits. This has very more number of core credits. Next is electives of 18. Instead elective 6 credits, means only one you can do. Lab course 1, seminar. But see the topics which are given here. You have computational thermodynamics. So this is something which is very different. See, in industry, if you go, you'll be seeing all the thermodynamic applications. Now you are learning everything on paper and pen. But when you go to an industry, you can't take any live example and do and sit with a pen and paper and solve all things. Computational thermodynamics is the one which will teach you how to prepare a model, based on thermodynamic parameters. Right. So this is the course which will offer you better understanding of thermodynamics and implying it in softwares. So you have one more course which is being offered here is thermodynamics of materials. This is an older course which have been removed from this steel technology and has been replaced with computational thermodynamics. So I prefer whether any branch you take it. This course also can be kept in mind for better understanding and any learning techniques. If you want, you can learn from this. And advanced physical and mechanical metallurgy is the one which you learn physical and mechanical metallurgy, all the mechanisms and all the deformation techniques, everything, all the failures in a very deeper version. Okay. Next is structural characterization of the steel, which is already told. Transport phenomena. Transport phenomena is one very important topic where it has gaining a lot of importance in GATE exam mainly. Rate process. You'll be learning all the applications of radiation, conduction, convection, and application of these in liquid steel mainly because of this is of steel technology. You'll be learning it in liquid steel. You'll be learning it different kind of furnace like roasters. You'll be learning it because of formation of fluidized bed roaster. You'll be seeing it in pyrometallurgy applications. You'll be seeing in horizontal furnace, reverberatory furnaces, blast furnaces, everything. Right? All these transport phenomena applications you'll be learning in a very good deeper versions. You'll be seeing the applications of fluid dynamics and the rate processes, fluid dynamics, fluid mechanics, and also these different kinds of processes also. Next is processing and characterization of steel. So this is a very good lab course where first you will be doing all the characteristic techniques. If you'll be working on a steel only. So first you'll start with preparation of martensite. So you'll take a steel, you'll heat it, you'll mark it at a different lengths. Then you'll see quenching, Jomny and quench test you'll be doing. Okay, this is a very easy course. But then the real thing starts. You'll be doing all the hardness tests. Okay. This is the first part. So you'll be doing processing of steel. You'll be in the processing of steel. There are different processes you'll be learning also. So characterization of steel, you'll be learning all this characterization techniques. Now hardness tests, you'll be learning it. Next, you'll be taking smaller steel parts and you will be learning about techniques which are used in different applications like tensile test you'll be seeing, torsion test you'll be seeing, isoid or charpy test you'll be seeing, creep applications you'll be seeing compression test, everything you can be learning in this process and characterization of steel. Next comes one more lab which is related to your formation of sinters, formation of the centrifugal castings, and next rolling techniques. And there are many techniques which you'll be learning in this, especially. Okay. Next is seminar. You can select a course and do. Next is principles of sustainable iron making. So this is something which is not like a basic iron making you'll be learning in your B.Tech. This is something which is very different in IITs. So you'll be learning about iron making, modeling of blast furnace, Modeling of the blast furnace is from the initial phase, from inputs and outputs, all the parameters which are required, how to maintain, what defects you will be getting, how much percentage of your temperature will rise if you raise hydrocarbons, how much temperature will decrease if you increase more humidity, how much temperature is increased or adiabatic flame temperature will rise if you increase more oxygen percentage. These are all things you will be doing and learning in the form of modeling. So you'll be trying to make a mathematical model using MATLAB, or you can use machine learning or Python also to prepare a model. So there is so much thing that you'll be learning. First phase will be learning about all the techniques in iron making, blast furnace, and you'll be learning about this DRI also. So all these things you can do in the form of model. Blast furnace model is something which you'll learn definitely from this. Next is principle of steel making, refining and casting. In this, you'll be learning about after the process ends near the blast furnace. From the steel making onwards, you'll be learning everything in this. Now in steel making, you'll be learning primary steel making, you'll be learning secondary steel making, then you'll be learning refining techniques, and then castings also you'll be learning it. So in steel making process, what you'll be learning, you'll be start with BOF, then you'll go to ladle furnace, then you'll go to refining process, desulfurization, these techniques you'll be learning. In this refining process, you'll be doing removing all these things and you'll be adding alloys. So secondary steel making is all about alloys. And then you'll be learning about special techniques like ESR and VAR processes, vacuum arc remelting, vacuum arc degassing. These the AOD, argon oxygen degassing, these all things you'll be learning in this principles of steel making and refining and casting. Next is thermomechanical processing and forming of steel. This is a very good chapter, very good course also. So in this thermomechanical processing, especially this is for persons who work in steel plant or who want to pursue a career in steel. So this course includes rolling, forging, the extrusion processes. You'll be learning a very deep insights of rolling. Rolling is a very big part. You'll be learning very good parts and implications of this. And then you'll be learning about wire drawing processes in deeper versions. Next, different kinds of forming applications like sheet forming, drawing applications like wire drawing, deep drawing. These are all things you'll be learning in thermomechanical processings. Especially nowadays, automobile sector is the one which is gaining a lot of importance over the steel sector, right? So you'll be learning about special alloys, different kinds of steels also you'll be learning it. You have HSLA, which is called high strength low alloy steels. So these are the ones which you'll be learning more in applications in this thermomechanical processing. Next is computational tools for analyzing of steel production. This was started with a course for computational tools for analyzing steel production, but not only steel production, you can apply this application to any kind of materials also. Okay. So what are the computational tools you'll be having? You'll be learning about again in MATLAB. You'll be learning about Python in this. And there are very older applications of nowadays we are using only Python. Previously, we used to do all these codings in C and C++ also. So you can learn these all computational tool analysis for the steel production. Next is project. Next, list of restricted courses. You can select courses which is related to protective coating, tops in mechanical behavior of material, numerical methods, topics in phase transformations you can take. Modeling for metallurgical process is also a very good course. Computational methods for metal forming analysis is also a very good course. High temperature processes and kinetics of those high temperature processes. Statistics and the probability for material engineer. This is one course which I like suggest students to take it, because statistics and probability implications you won't be learning it again, which is being offered to MBA students a lot. So you are getting an opportunity to learn all these courses. So please make a use of it. Next is machine learning for material sciences, material engineering. Now in this machine learning, you'll be learning machine learning, learning Python is not a very different thing which you need to do. But what we do is, when you go to plant as a material engineer, when you go to any industry as a material engineer, you are the one who decide what parameters are required for modeling of these materials. So learning machine learning is a skill. but who will tell the parameters for manufacturing a new material? You. So you need to have this skill, and what parameters, what techniques, what temperatures, what the conditions you require, what atmosphere you require, all these things can you will have a knowledge by doing these specializations. But machine learning is a something which is an implication to material engineering that you will be learning only in this course. This is also a very good course. So you can select out of these any of the courses. Physical and mechanical properties of steel is something which you can do easily, because these are the courses. If you select, it will be very good. Protective coating, diffusion kinetics, and next you have high temperature processes. These are all things you have. Now let us see about the newer courses which are added. So we'll complete this materials manufacturing and modeling. So what is there in this material manufacturing and modeling? So you have advanced physical and mechanical metallurgy, which is common for them and steel technology. Next, you have structural characterization and mechanical characterization. Advanced manufacturing processes. You learn about machining, which won't be there for metallurgical engineer. This is for mechanical engineers. So you will be learning about machining and forming. You'll be learning machining process as a part of course. These are core courses. You'll be learning about deformation processes. So these deformation process, you'll be learning about how to do deformation maps, how to do modeling for this deformation maps. So what are these deformation maps? At lower temperature, what kind of processes will happen? At higher temperature, what kind of deformation processes will happen? At higher temperature, especially you'll be having main deformations with respect to creep, diffusional creep, and the latticed creep, or diffusional creep you can say, or these processes, modeling of these also can be learned from this course. Next, you'll be learning about welding processes, liquid material processing, advanced heat transfer. This heat transfer which you learn in B.Tech is nothing compared to this advanced heat transfer. The advanced heat transfer is such a topic where you'll be learning or getting a very good insights about how you apply it to a very higher, because mechanical people learn it to very extent in their engineering itself. So advanced heat transfer is such a way that in industries what kind of applications do they need, you'll be learning them along with models. Okay, next is stress analysis. Stress analysis is a little different what we learn from metallurgical point of view. Next is suggested electives. Let us see these courses. So as they are a part of metallurgy department, they also have process and characterization of steel. Next, restricted elective, you can take mathematical models, methods in engineering. Reliability, I told you, like this used to be a part of mathematics department previously. So those courses are also there, which are taken, which you can consider them as restricted electives. So mathematical methods in engineering. Reliability, modeling and analysis for engineering system is nowadays, which is gaining a lot of project importance for them. Reliability modelings. So you can use machine learning for this. You'll be taking lot of information, lot of data you'll be taking, all the data which are related to the parameters. They you'll prepare a reliability model based on these analysis. Next, engineering data mining and applications. This is also a course, very good course for which can be useful for your project applications. Next, you have suggested elective courses. You have advanced iron making concepts, steel, advanced concepts in steel making, thermomechanical processing of steel. Fatigue, creep, and superplasticity is the one which they learn in very deep. And it is also a very good course. Fracture mechanics and failure analysis, welding science and technology, physical metallurgy and mechanical metallurgy, additive manufacturing with the metals. So X-ray diffraction and ultra microscopy is the one they'll see. Statistical design for of experiments, statistical quality control, convection heat transfer. You learn everything about convection heat transfer and mass transfer. This is very much important for your chemical engineering department also. Next, two-phase flow and heat transfers you'll be learning. Computational fluid dynamics, CFD is the one which you will be learning in a very good extent. If you want to do any, if you want to join aerospace industries as a material scientist, CFD is the one which you need to learn for modeling applications, so especially heat transfer and CFD applications. So this course will help you. If you do this course and you do a project which is related to aerospace applications, definitely moving into that industry is like very good opportunities you'll be having it. Along with that, you also need to have one more course which is called as FEM. This one, finite element and boundary element methods. This is the course which you need to do in order to move towards your aerospace application if you want to pursue a career in this, because modeling which is related to finite element analysis is the one which they require as a mechanical engineering a lot. So if you want to move towards mechanical background, so this is a course I suggest you to do. Next is numerical methods, modeling of manufacturing process, computer integrated manufacturing. They have a lot of courses nowadays which is related to directly machine learning, Python or coding. So nano manufacturing process, combustion in automobile and gas. If you are more interested in mechanical engineering, you can do this. Introduction to microsystems, moving boundary problems in solidification, computational structure dynamics. You have lot more courses in this. This is a course which is offered by civil engineering, finite element methods. This course also you can take instead of that course which I have shown previously. You can take introduction to machine learning also, which is given by electrical department. This is a very good course. The professor is also very will teach very good. So this course, he has a lot of very good connections and collaborations with a very big industry. So he'll be bringing you real time projects. So if you do those projects, if you do those implications, definitely you'll be learning very good about machine learning. This basics are enough for your non-core jobs, especially thermal environment engineering, computer numerical control and programming, statistics and probability for material engineering, simulations and optimization, MEMS you can take, and introduction to microsystem, material processing and semiconductor device. This is also a very good course where you will be learning about all the process which is being processing of the semiconductor devices. From processing, how to form the materials also, you learn all the basics and foundations required for this. Now let us see the new courses. So in new course, you need to do at least four core courses. Electives, you need to do at least four. Then institute elective two, lab courses, you need to do two, seminar one. And communication skills is a bonus. Actually, this is plus six. You need attendance for this. That's all. So core courses is 70 plus six. Project is 90 credits, which is fixed for everyone. Now, what are the specializations offered here? So first thing is differential equations for modeling of transport phenomena. This is a major application. See, all the things are related to your software purposes only in this computational material engineering. So what are the things which you will be learning? Differential equations for modeling transport phenomena. So if you have a basic understanding of transport phenomena topics, or before you take this course, the main things what you need to do, I'll be giving you an idea and suggestion about this at the end. So you have differential equations for modeling transport phenomena, computation lab, restricted data and department electric, you can take it. We'll see the courses. So case study in multi-scale modeling of materials. This is the project which is going on right now. So on multi-scale modeling of materials, you'll be taking different case studies and observe its applications. You'll be learning each as a case study. So computational lab, you'll have restricted elective, open elective. So what are the restricted electives? You have machine learning for material engineering, modeling for metallurgical process, simulation and optimization you'll be learning, statistics and probability for material engineering, computational thermodynamics, modeling. All these courses are very good courses. So if you are confused to take what kind of course you need to select, also I'll be giving you a suggestion at the end of this video. Please watch it. So you have project stage 1, stage 2. Okay. Now coming back to the question. So now suppose if you want to take a course in this, so your core courses is something which you can't avoid. So differential equations, modeling transport, computational model, next seminar, restricted, all these courses you'll be taking. Now, if you want to select out of these two, you can do only one restricted course. Let us take an example. So how many restricted courses you can take? Restricted electives. It's not mentioned here. They'll be giving you an idea. So you can take either of the two courses, either of the following two courses. If student take both, they need not register for specialization. Okay, out of this, let's take an example. You need to do only one restricted electives. They have given you a list of these restricted electives. They gave you first principle approach to material science, introduction to ab initio, molecular simulation for material science, numerical methods in material processing. So these are out of these four, you can select only one restricted course. Let us take an example. So now, if you wanted to do more than one course, what you can do? So out of these four, you can select one as your restricted elective. So you have done this course. Suppose if you are not satisfied with this course, in the next semester, you can select again a restricted elective and do a topic on which you want to do. Suppose if you get good score in that course, you can replace the old restricted elective with a new restricted elective. Then whatever course you have learned, no, even if you want to learn more courses, you can register them and learn as ALC, which is called as additional learning course. So you can select courses which you want to learn extra. So there was one of my friend who has done courses on, though he was metallurgical engineer, he has done courses on electrical engineering branches. He has done courses related to electronics engineering also. So how can you do it? You just register to them, seeing the slot availability, and you can do it as additional learning course. Or if you want to do it as, no, I don't want, additional learning course is something which you'll be getting credits also. So if you think you don't want to do for credits, you can take it as a non-credit course also, which is called as audit. So it is just a pass or fail, but you can learn something which you want. But I suggest you to take it as additional learning course, because you'll get marks for it, you'll also study for it. If there is something without marks or exam, you don't concentrate much on it, or you won't give much importance to it, though you want to learn. So always it is better to take as ALC only, additional learning course. You can take a department elective, electrical applications, and topics in mechanical behavior. So these are the topics you'll be learning. So computational modeling, machine learning, simulations, probability. So machine learning for material engineering, if you want to start with this topic, I suggest you to take this in second semester or third semester, because suppose if you take it in first semester and you're not good at basics of machine learning, then you can't complete this course. You'll struggle a lot with this course. Okay. Again, you can't retake this course and improve yourself. So always suggestion is learn something in summer itself before joining your M.Tech, or learn something after you join in the first semester, avoid, put some time for you, and then you take this course in your second semester or third semester. Next is semiconductor materials and processing. Now, this course is nearly 39 credits. So core courses in first semester is 24 and this is 15. Next, electives, you can do 2 electives. Institute electives you need to do in second semester and third semester, you need to do 12. Because your core courses are more, they are not giving you anything as a institute elective in the first semester. Next, you have a compulsory lab course. Next is seminar. Next is communication skills. So let us see what are there in this. Structure and effects, it is common for material science and semiconductor. So semiconductor, why they have done previously semiconductor topics, all of them which you will be seeing now has been included in your material science itself. But why they came out as a special branch? Because semiconductor companies has grown a lot. The requirement to the semiconductors, metallurgical scientists has improved a lot. Metallurgical engineers also, material scientists especially has improved more in number, and their applications projects were coming more in number. So what IIT Bombay has done is they have taken it out as a separate course, and then they started especially concentrating on semiconductors materials. So what are they? You learn about electrical materials, fundamentals and applications. Material processing in semiconductors. This is the technology which you'll be learning as part 1. Remember, this is material processing in semiconductor technology. All the semiconductor properties or processing you will be learning in the first part. These are basics and foundation. Next is electrical characterization, which is very much required for your understanding. Structural characterization, because suppose if you prepare a material, you need to do some XRD, you need to do some SCM analysis. So structural characterization is the one which is definitely required for everyone. Next is Semiconductor Processing and Characterization Lab 1. So in this, you'll be learning about how to process this material. There is something which is called as different kind of materials also you have, where you'll be having microsystems also, how to process them, how to prepare them, how to characterize them, you'll be learning in this communication and presentation. Next, now you have material processing and semiconductor technology part 2. This will be little advanced version. You'll be seeing more of material processing and technology. Next is semiconductor device and their working principles. You have open optical characterization of materials, open elective 1, institute elective 1. Semiconductor processing and characterization lab 2. So in first semester, you have a core course. So this is, see, what is this mean? What does this mean? You need to understand. So semiconductor and processing characterization lab 1. So you'll be learning material processing and semiconductor technology, no? So this is slightly related to the see MM762, MM763. So whatever technology you are reading here or learning here, you'll be applying it in the lab scale. Next, again, you'll be having semiconductor device and the working principle, material processing 764. This is a continuation for this semiconductor processing and characterization lab 2. Next, you have seminar. Next, you have project. That's all with this. So restricted electives are again same. You can take diffusion kinetics. You can take organic semiconductor and devices. Mainly, you can take material and process for semiconductor devices. You'll be learning about semiconductor photoelectrochemistry and photocatalysis. So you'll be learning about magnetism and magnetic material, superconductivity, thermoelectric material. So thermoelectric material are something which is gaining a lot of importance in plants especially. So what are these thermoelectrical materials? Suppose there is a furnace. So at the furnace, you will be having lot of temperature surrounding it. You take an example. What is happening to this radiation? What is happening to this heat? It is being lost as radiation. So what can you do with this? So you stick this thermoelectric material to this furnace. So it absorbs all this energy. It absorbs all this energy, convert this thermal energy into electrical energy, and you can get electrical energy there. So your these are the materials which are being providing the electric converting this thermal energy into electrical energy. So they are working on it and they are very sensitive to temperatures. Next is optoelectronic property, material and devices. You have first principles approach to material sciences. Then you have principles and applications of ferroelectric and piezoelectric materials. So piezoelectric materials are also one which preparation is easy, but working and standardizing it is very difficult. Next is advanced ceramics. Now let us see what are the open electives present to your what are the open electives present for your subjects. So you can take instrumentation and process control. Huh. So this is one I want to tell actually. So this instrumentation and process control is something which is for your B.Tech students. So our courses generally start with 6 and 7. So can't you take this course? Yeah, you can take it as an open elective course, but this is a course which will clash with your class timings also. So be aware of this. So instrumentation and process control, if you take it, this is a course which is directly related to one of the lab techniques also. So in this, you'll be learning theory in the class and you'll be learning all the applications in the lab scale. So what are the things you'll be learning? You'll be learning about the um, thermoresistors, you'll be learning about it. You'll be learning about implications of fluid dynamics also, you'll be learning it. You'll be learning implications of all electrical applications on the materials, all these things, all instrumentation related and process control related techniques you'll be learning in this process, which mainly is for modeling only. Advanced physical and mechanical metallurgy, mineral processing, surface engineering, modeling for microstructural aviation. You have advanced additive manufacturing with the metals. You can take machine learning for material engineering also out of these courses. And if you want to select out of these, uh, material processing for semiconductor device is the one which is gaining a lot of importance. X-ray, diffraction, and electron microscopy is the course which you can take. If you want to learn something in corrosion, you can take the advance in design corrosion control for industries and aqueous corrosion control. Next is if you want to use high temperature corrosion, you can learn lot of things about corrosion also. Fatigue creep superplasticity is the one which you can learn. And next is fatigue materials. I see finite element methods is the one which you can learn if you want to join any aerospace industries. Semiconductor, photoelectric chemistry, and these are not very much required. If you want to learn, you can learn about just for your interest, you can learn about sustainable materials for water treatment and finite element method. You can learn characterization of pattern. So mostly whatever courses which are related to computational modeling, computational method for metal forming analysis, and next machine learning for material engineering. And if you want to learn math, science, and engineering entrepreneurship, you can join this also. So these courses are the one. What will happen is if you learn these courses or if you want to take these courses, I suggest you to please take it as um, one core course you can take it, and remaining courses still, if you have time in your third and fourth semester, if you want to sit for your placements, make very good planning such a way you can complete at least one or two machine learning courses in your first and second semester courses only, so that you can be ready for your non-core jobs also. And the career, and now let us talk about that later. Now, what you can do is you can take extra courses as additional learning courses in your third and fourth semester courses. Suppose if you want to join a job, or if you want to join something, you want to participate in an off-campus placements. So there you can use these techniques. You can do some mini projects which are related to it. You can do some mini projects, and then those courses you can highlight them in your resume, showing that you can apply for a very good companies. So, as a material scientist, what are the sectors you can do? If you take material modeling and material modeling and manufacturing course specialization, you can move to automobile sector, you can move to aerospace sector, you can move to any mechanical background, or the machine learning non-core jobs, or you can move to these metallurgical jobs also. If you take material science, generally you can move to these semiconductor industries, battery industries, or a non good set of non-core jobs also. Mainly corrosion is for you can move to very good companies, like there are oil and gas companies which pay very good especially for M.Tech students from IIT Bombay. They'll pay like more than 20 lakhs also. There are companies like Chevron which pays more than 25 lakhs. You can apply for it. There are companies which apply especially for corrosion only, like if you are very good in characterization techniques, there are company like applied materials, and you have KL10 core. These companies are such way, like if you learn better techniques along with these characterization also, you have a very good scope of getting placed with very good packages. Then you have material science, then you have computational modeling. You will be very much equipped, or very much familiar to non-core jobs. Mostly everything is related to modeling here. Mostly everything you can do which related to machine learning modeling, optimization techniques you'll be learning it, modeling related to this machine learning models you can do, the computational thermodynamics you can learn, drawing phase diagrams, or any software and modeling application material companies, you can apply to them for a very good packages. You have companies like Micron which offers like 25 lakhs packages, and you have very good companies also which offers very good packages, just learning this modeling and machine learning apart from your technical courses. Next, you have semiconductor. Semiconductor is the one which is going to boom in future. Definitely, if you do this course, you are nowhere. You were nowhere lesser to these electrical and electronic branches also, which will get a very good pay. So your average packages also will start from more than 20 lakhs only. So you can do very good, learn good techniques, learn, become stronger in these foundations. Learning semiconductor industries, you will land somewhere in semiconductor companies, or you will learn somewhere in battery manufacturing companies, or you learn somewhere in modeling companies, because most of this part is also modeling related. You learn somewhere in characterization technique companies which require a lot of characterization technique analysis. So these are the things which you will be offering. So apart from this, suppose if you want to learn more courses also, you can select open elective courses, you can select institute elective courses, you can select. So most of your time will be free. So first and second semester itself you'll be having a lot of courses to do. After this you can select courses, you can do some additional courses, additional learning also. You won't get a chance again to do this. So select these courses and do it, become a pro in it. Then you can apply to very good companies. Though you have a very good offer in your hand, you can apply still more companies which goes to different IISc Bangalore or IIT Madras also. You can apply for them. So those companies, you can send resumes to those companies saying that you are specialized in these courses. So that's all for today. Next we'll see for different M.Tech courses offered in different IITs. So most preference or first preference, please give it to IIT Bombay. Next for IISc Bangalore. It depends again from the person to person. Best always will be if you are thinking of both the core and non-core job. If you are not confident whether you want to go to core or non-core, be aware that go to IIT Bombay is a very good option because both core and non-core opportunities are very good in IIT Bombay. Suppose if you are stubborn that you want to go into these core jobs only, then please be aware that going to IISc Bangalore or IIT Bombay or IIT Madras will definitely help you to get, because research and projects which are going are very good in IISc Bangalore, IIT Madras and IIT Bombay. So getting a core job placement with a good packages is also very good opportunity. Think these in mind and then you decide. So why I decided to explain all these things related to IIT Bombay is because it offers a wide variety of specializations which other IITs are also providing it. But for metallurgists, we have these many opportunities to move on. Okay, you can do a minor course in mechanical engineering also. There are some certain criteria. You need to finish at least 30 credits in the other branch to get a minor degree. So along with your M.Tech degree, you'll be getting one more degree from mechanical engineering department also. So I suggest if you take it, it will be a very good opportunity for you so that you can be placed in mechanical companies also. That's all. Thank you guys. Please follow the channel for more updates. Please click the notification and bell icon. Thank you.